Okay. Hi, everyone.
Hi.
Okay. It seems like everyone was waiting for me to talk.
Yeah.
Okay, cool. No pressure.
No, no.
Yeah. Yeah, so I think we're good to kick off. I'm guessing everyone that needs to be on the call is already on the call, so I'll just be starting off now. So as a matter of introduction, my name is Femi Ogunbode. Okay. Yeah, so yes, my name is Femi Ogunbode. I am a data scientist at Indichina. Indichina is it's a startup, still very new. What Indichina is trying to do basically is build the credit infrastructure for financial institutions in Africa. Obviously starting from Nigeria. So what that means is the technology that powers credit scoring and risk modeling for financial institutions. We're trying to build that such that financial institutions, so like banks and non-banks, lenders essentially can plug into our system and make credit decisions based on data they have on their own customers. So I'll be backtracking and I'll talk about how I got started with data science and my journey from when I started to eventually getting to where I am now. It's not been really long, it's been like 3 years. So not a lot has happened, but I'll just try to summarize everything. Yeah. So is everybody on the same page? Just checking in.
Yeah, we are. Yeah, we are. Sure.
Okay. Can everyone hear me?
Yes, we can.
All right, great. Okay, so my interest for data science started. Okay, it's okay. Yeah, so my interest for data science started in late 2016. I think I was leaving school then. Trying to figure out what I was going to do for master's degree, which I haven't done yet. And as at then, big data was trending. Everyone was talking about big data. So I figured, let me look at it and see what it's all about. After like weeks, months of research, I was like, okay, you know what, this is not actually that bad. It's something I can try to get into because it seemed interesting at the time. And so, I started the journey officially like January 2017. So basically, I started off with online courses, articles, trying to meet up or try to link up with mentors at the time or people that were already doing data science. So I took a ton of courses from Coursera, Andrenji's the popular machine learning course, a ton of courses from Udacity also, Udemy. Then I tried to, meet up with people that are already doing it. Unfortunately, we didn't have like a lot of people doing data science at the time in Nigeria. So I had to find people that, were Nigerians, but were doing it outside the country. So I got people from UK, someone from UK, somebody from America, and I think, yeah. So two people basically that anytime I had questions, I was grateful to have that. So that whole process lasted for 18 months. So the process of learning stuff, taking online courses, meeting up with people, going for meetups. I also was part of like Data Science Nigeria's bootcamp. I went twice. So going for all those kind of stuff made me meet new people that we had similar interests. So that whole process lasted for about 18 months. At the time, I was working at 21st Century as an intern. So that lasted for a year and 3 months. So it was during that period I was also going for all these meetups, taking courses and whatnot. So so from January 2017 to up until mid 2018. So that was June 2018. So that's 18 months. I I got I heard about an opening through a friend I met, also through like the whole machine learning thing, and it was a Terragon group. So they were hiring for machine learning engineers at the time. So I decided to apply, and I was lucky to get in. So that kind of started. I would say that's where my career officially started. So July 2018, that's where it officially started. So I was hired as a machine learning engineer at Terragon Group, and basically what that entailed was building it entailed building machine learning solutions for their advertising platform. So Jargon had like an advertising platform where they try to connect to consumers via online and offline channels. So offline channel was via SMS, and online was via online advertising. So they had a team to try and make what they were doing more intelligent, in the sense that they wanted to be able to target the right people at the right time. So whenever they were sending out messages, they wanted to make sure that based on people that have clicked on their past ads, are we sending out to the right people? So that lasted for a year and a half or so, up until last year December. So I spent a year and a half with them up until last year December, where I joined Indichin as a data scientist. So that's like a quick rundown of how I started and what I've done so far. And I don't know if this short summary covers everything, but I hope it paints a picture of what I've been doing for the past 3 years, what I've been doing from when I eventually got the interest to landing a job and doing what I do now. So just a quick check-in. If anyone has a question, can you please signify? So I think like 1 or 2 questions before I go into the main presentation.
Hi, Femi.
Hi.
Can you talk about your experience as a machine learning engineer, and your day-to-day? What do you really do? What does the job?
Oh, okay. Okay, cool. So as a machine engineer, what it entailed was, after building the models, right, we want to be able to use them, we want to be able to deploy them into production, such that if there's another software or an app that, for example, we had the marketing software that used to send message. So my work was to build a smaller system that fits into that messaging app, such that before they send messages out to people, they kind of get a score from my own system before eventually knowing who to push messages to. So it was all about building models, deploying the models, also building like APIs for the model, which is deploying models. So that's what we're talking about here. So after building the models, once you expose their functionality to like a bigger system, so I was doing that, building APIs, and from time to time writing some SQL queries for other teams that might need, some insights. So if a campaign went out yesterday, they want to know how it did, who are the people that performed well, who didn't do well. So those basic query stuff, I did that also. And also we had like an element of statistical testing. So if we had some hypotheses, we wanted to be sure that whatever we tested for, it's backed statistically, so that we're not making bogus claims. Like, sometimes like correlation doesn't necessarily mean causation. So because something happened doesn't mean that that's what influenced it. So to take away that guessing factor, you try to do statistical testing. So like those were some of the tasks I was doing at Stervan as a machine learning engineer. That was my day to day. Does that answer the question?
Yeah, it does. Thank you.
Great, great. I think I can take one more before I start the presentation. Okay, I guess there's no question then. I'll just jump right to the presentation. Just give me a minute. Let me share my screen. Sure. Okay, can everybody see my screen? And can you confirm is the presentation as in your screen also?
Yeah, yes.
Great. Yes, so I tried to put slides together to deliver the topic I'm talking about, which is developing APIs, and more importantly, developing APIs for data science, because developing APIs is more like a software engineering topic, if you may. So it makes sense to kind of explain it in context of data science. Yeah. So pardon me if my slides are not so catchy. Not my strongest. Developing slides is not my strongest suit, so just bear with me. So we start off by okay. Yes. So I mean, obviously, data science, developing models, testing out assumptions and whatnot, data analysis, all the stuff is really cool, right? Until you have to go through the nightmare of deploying your model into production. That's where it's like there's a lot of grunt work there. It's not as fun as the other parts of the job you get to do. So that's it's really not fun, and you don't get so much credit for it because you are expected to do that. Yeah. So as form of introduction, I'll be trying to cover 4 main touch points in the entire presentation. So the first would be understanding why we need APIs to deploy data science solution, how to build a simple API for exposing our data science models, best practices when you're building data science APIs, and handling large-scale deployments. And for that, so look at AWS SageMaker as a case study. So at the end of the presentation, if I didn't get any of these points successfully, please feel free to ask any questions. I'll be more than happy to answer your questions. So yeah, let's start. Why do we need APIs? I mean, I'm sure there are a ton of other ways if you wanted to deploy your model that might not necessarily go to using the API formats. I've been in situations where a client is not so should I say digitally inclined. So the system they have is kind of manual. So the way we used to do scoring for them, credit scoring for them, was they would send over an Excel sheet, and we have our models that we use locally, and we score for them on our machines locally and send back an Excel with the corresponding scores. So that kind of system is very manual. It doesn't scale, and it's prone to a lot of errors. But again, that's just a unique case. Ideally, you would want a very programmatic system where everything is accessed via APIs and whatnot. So obviously, after doing everything you have to do for building your models, so you want to predict user risk profile. So user risk profile is basically credit risk. You want to know how probable a user is um, to default on the loan. You want to know how risky a customer is, right? Or you want to know the probability of a user clicking on an ad you sent out. So, I mean, obviously, the business goal is not to have all these models we've developed. We don't want it sitting on our laptops and just being there as a proof of concept. We want to deploy it, right? We want to fit it into a much more bigger system. Yes, so I mean, an example would be, for example, when a bank needs to approve loans that are accessible via a USSD channel or web portal. So when you apply for loans on, for bank loans, you most likely, and most banks are using, USSD, right, or a web portal, or even like the mobile phones to apply for loans. Now, you that are building a credit risk model, you have to somehow fit whatever you've built into this larger system. An app company needs to send out adverts via SMS. Like I explained what I was in at Terragon. So these are like the scenarios you find yourself in. And essentially, USSD, web portals, all these things are software systems. They're built by software engineers and they're deployed somewhere. And I mean, what other obvious way to integrate our solutions or our models into these systems than, wait for it, API. So API is, it makes sense, right? Because all these systems, if you want to build other smaller systems that communicate to them, you need to do it via APIs. So I don't know if everyone here is familiar with APIs. I think that's a good starting. Is everyone here familiar with APIs? Is everyone familiar with APIs?
A little idea from Twitter calling out.
Sorry?
We've done little, we've crawled on Twitter. So yes, we use Twitter.
Okay, that's cool then. So I mean, a very high level and layman explanation of what an API is according to this explanation that go on Reddit is, if you're in a restaurant, you have the menu. I know what the kitchen is making, right? But you want to order for it. How do you know what they are preparing in the kitchen, right? So there's a waiter that comes to you with the menu. The waiter is like an intermediary that knows what's happening in the kitchen. And the waiter is also the person that takes your requests, right, to the kitchen and comes back to you with a response from the kitchen. So yeah, you have something like this. Your API is, you can consider API to be the waiter, and this guy here is basically you trying to make requests, right? So the API takes down your requests, and once it has gone to the kitchen and come back, it basically returns what you asked for. So that's a a very simplified way of thinking about how APIs work. So I'll be walking us through a code example for, I shared a folder. I don't know if everyone got it. Did everyone get the folder I shared? Okay.
Presentation. Is there any other folder?
There's a folder sent. Okay, it seems like we didn't get the folder. How do we do this? Let's see. I think we'd have to carry on without. I can share the folder now, but I don't know how long it take you to set up. So first of all, do you have Flask installed on your machine? Just show of hands if you have it installed. Okay, no, that's fine then. I can walk you through the setup for my own system. Then in your free time you can try it out on your own. I'll share it after the call then. Is that fine?
Yes. That's okay.
All right. Sorry about that. So before you build your APIs, you need some requirements like some library requirements and and some other things. The first thing you did is a Python file. So a Python file that handles routing, authorization, and the prediction logic. So routing is basically defining how your API endpoints will look like. So if it's going to be, your domain name slash API slash version 1.0 slash predict, or whatever style you want to use, you'd have to define that, in the routing section. So your Python file, right, has that. And there's also authorization, where we only want people that are meant to have access to it. So we don't want just anybody to be able to access our APIs, right? I want only you guys in this course to be able to access it. So using like basic authentication, which is using username and password. There are several other authorization techniques, but for this simple, I'll just using like a simple username password authorization. Also the prediction logic. You have your model. How does the model make the prediction? So that's basically what your Python file has. You have your model file, right, which is the result of all your modeling efforts. So when you build your model and you pickled it, so you have to also put that in your project folder. Also, your laptop that has Flask and other data science libraries installed. So other data science libraries would compose of NumPy, Pandas, maybe SciPy. Is everyone familiar with those libraries, NumPy and Pandas?
Yes, we have.
Okay.
Familiar.
Great. Oh, great. So, and also Flask. So Flask is a web framework for building web apps using Python. So I will just be running. I would share my screen that has the project. Maybe we can see how it's done. Okay. Can everyone see the code screen I have in front of me? So I'm sharing my screen right now that has the code I've written. Right? Can everybody see it?
The slide is still showing.
Oh, the slide is still showing. Stop sharing. Yeah, how about now?
Yes, we can hear you and we can see your
The screen.
code.
Okay, great. Okay, great. So you need this single Python file for a very simple web API. So the first three functions we have here, these three functions are for this is where we define the authorization. So there's response okay and there's response error depending on whether the user is authenticated. So these are just basic. You shouldn't bother too much about this. The code is kind of straightforward. You have like the check authentication header that gets the username and the password and checks, I've set the username to certain user and the password to certain password. And depending on if the person gets it right, it returns a it returns a successful message or invalid message. I talked about the routing logic. So this is where the routing logic, this is where we handle it. So when we eventually deploy this app and we get our domain name, we have to attach this route to the back of the domain name to access the functionalities of this API. So this is basically the route, and it's a post method because we're going to be sending some data to the server. Right, so you define a predict method that has the validation for the authentication header. And the next thing to do is you try to get the data that whoever is sending the data from the request. So you have to get it in JSON. Read the data into a pandas data frame. Then next thing is to have your model, loading your model into your code environment. So you have to load the classifier. So I built a model for classifying the iris classification project. So I just use that. It's a popular machine learning model. So I just use that. So it basically predicts the type of flower it is based on the height, the sepal height, the sepal width, the petal length, and the petal width. So those four features. It tries to determine what kind of flower it is. So you read that in, you load the model. You call it does predict like you do normally. You call it does predict and return a a JSON object of the class and the corresponding flower type. So this is I'll clear on this code so we can see the output. Just a minute. So all this thing I'm doing, I already kind of defined it in the slides. So I'm sure you find it in the slide. That's gone. Just give me a minute. Still trying to, yeah, export. Yeah. Okay. So I've started the web server on my system locally. So you can see the 7 Flask app API, and it's running on our local host since I'm deploying it locally on the machine. So I'll just switch to Postman now. Yeah, so can you see my Postman screen?
Yeah, we can.
Yes.
Yeah, we
Yes.
can.
Yeah, so the Postman is what you use to test your API endpoints locally. So you have the authorization. I've defined the basic auths and its username and password. The body. So we send the JSON, right? Then when you click on send, so I'm making a call now. Yeah. So this is the result of, so we're trying to make predictions for this particular flower. So this flower has a sepal length of 0.3, a sepal width of 0.5, petal length, blah, blah, blah. And the class is 0. So there are actually 3 classes. There's 0, 1, and 2. So those numbers, they actually map to the kind of flower. Let me quickly see what kind of flower it is, but I can check that later and send it. But basically, we use 0 because computers don't understand text. So when you're making predictions, you're just taking in a bunch of numbers and spitting out a number. But essentially, this number that is spitting out, which is 0, it maps to some other like text, which is the name of the flower. I don't have that right now, but I would share. So essentially, there are like 3 classes. There's the class 0, there's class 1, and class 2. So this is like how to set up, this is how to deploy a machine learning model locally on your machine. So we've basically built an API and try to send a request. This is a request here, and we've gotten a response. Based on some logic we've defined in our API. I hope that's clear.
Yeah, to an extent.
Okay. I think it would have been, way better if we all had like the folder and everybody could do it, have like a code session. But once again, sorry that you couldn't get the project folder, so we can test this out. But I'll send
the project folder.
Oh, okay.
Just for the project folder, can we like set up first quickly so we can?
Yes, you can. Yes, you can set up. Yes, definitely. So if you have Flask, Pandas, and NumPy installed, and also sklearn, you can definitely set up. So you just need to open your. You just need to cd into the project folder. Once you've downloaded it and you unzipped it, you just need to cd into the project folder and run like a bunch of commands, which is what I did. So if you have it up, I can, I can walk you through how you can do this locally on system. So do we do that now?
Yes, I think that was it.
Okay. So for the commands, let me share the slides again. So you have the commands on the slides I shared. Let's see. Hello?
Hello.
Yes. So sorry. I had an issue with my laptop. So I'll be able to use it for now. But I'm calling in from my mobile phone now, if that is fine. So sorry about that.
That's okay.
Okay.
Yes. I had some issue with my laptop I had to fix, but apparently the issue is back, so I can't use it now. So I think we can still continue. So has anybody been able to set up the project folder?
I have set up the project folder and I've installed the Flask. So I think
Okay. We have pandas and NumPy and SQL also.
yes, I do.
Okay, cool.
I don't have SQL on.
Oh, that might be a problem. We need to install. You need to have SQL because when we make the prediction, right, it's going to try to look for SQL because use the SQL library to build the model. So could you please install SQL also?
SQL is already installing.
Oh, okay, it's installed already. Then that's fine. That's fine. So let me share out on the page 9 of the slides. There's some commands I put there. Let me share my screen. Okay, can you see the slides now? I'm trying to share my screen.
Yeah, we can.
Oh, okay, great. So
Page
on this,
8,
page 8. Yeah, exactly. So so can you from your table now, can you see this in project folder? Have you done that?
So you didn't get that.
Okay, can you CD into the project folder? So you have to open
Yes,
your
we've
tab.
done.
Okay, then so next thing you do is
So
can you type in that?
we've not done that.
Okay. Also you need Postman installed. So does anybody have Postman installed?
No, not yet.
Okay. It's gonna take a while then. So does anybody have the requirements, the full requirements so far?
Yes, I do.
Okay. I think I can just walk you through it while others try to get set up. Is that fine?
I think it would be nice if we go with others.
Okay. Okay, that's fine then. How about now? Does everyone have it? Does everyone have the requirements? The Postman and the other libraries installed?
Yes, most of us have it, not all, but I think we can go ahead.
Okay, please let's go ahead. We are kind of behind schedule, so so I yes, so we can, first we can CD into the project folder. So have you done that?
Yes, yes.
Okay, great. So you type in this command, but before you type it in, are you all using a Mac, or some people are using Windows?
Mostly Windows, but we have a Linux.
Oh, Linux. Okay, I think this should work. I think so. So I think for Windows user, it should be set instead of export. So if you have a Windows system, please, can you replace the export with set? So it should be set, then Flask app is equals to API.py. Please, can you try that and please let me know if it works? Yeah.
Am I supposed to get a response?
No, it should just jump to the next line. It should just move to the next line once you type in a command.
Okay, did that already.
Okay, so can you go ahead to type in the next line? So set Flask debug is equals to 1 for Windows, and for Unix based, you can use export Flask debug is equals to 1. So have you typed it in?
Yes, it also did not give any response.
Okay, just jump to the next line, right?
Yeah.
Okay, then just type in Flask run and let me know the response it gives. So what's the output of Flask run?
So, it says could not locate the Flask application. You did not provide the Flask environment.
Oh, but that means the Flask app, the first command didn't work. Is that on the Windows system?
Yes, that's a Windows system.
Okay. Can anyone try on a Unix based system, so a Linux or a Mac? and let's see the response it gets. So for Windows, you're supposed to use set instead of export. But let me quickly check if that is. Okay, for Windows, can you instead do Python then API.py? So you run it as a Python file.
All right, I'll try that now.
Yes, please try that. So did that work?
It didn't give me a response. I'm waiting for the response. So it's still.
Oh, okay, still okay, that's fine.
So you're saying running on HTTP, blah 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 blah, but
Oh, great.
Control C to quit.
Quit. Yes, 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 yes. So yes, we are doing it right. So what that means is we basically started a web server. So our web server is set up in such a way that we can send requests to it and we can get a response. So the app we're building is supposed to be hosted on that web server. So I think the address is going to give you now, it's HTTP 127.0.0.1, then colon 5000. So exactly. So that is for a that's local host basically. So it basically means that you are hosting a web service on your local machine. So to call, can you open Postman?
It's
If you have it
open.
installed. Oh, it's opened already. So can you create a new request? There should be a button at the to create a new request. Have you found it?
Yeah, press create a new request, but it's asking for some details.
Okay, so it's going to ask for the key value. So it's supposed to ask for the website, like the URL. Is it asking for URL? Yeah. So the request URL in the slides, there's a URL on page 8. So you can see the URL of two things. It's a combination of the local host server and the route we defined in the Python file. Does that make sense?
Yeah, it does. It does.
Yeah. Our URL basically.
So do I put in that link inside?
Yes, that's the
URL.
link. Yeah, just put it inside as the URL. What else is it asking for?
Send or save.
Okay, it's supposed to ask you for the method. Is it asking you for the method? Or just save it. You can save it, then open it. Have you saved it?
I'm still saving it.
Okay. So once you are done saving, you can just open it. Then we can edit it before we finally send.
What does it mean by select the location or folder to save to?
Okay, you can select any folder on your laptop. You can save it to desktop or documents. It just is a location on your hard drive to save it to. Is that what it's asking for? Is it a location or okay? I think you need to create a folder first. Can you try creating a folder first?
How do I create a folder?
There should be the option should be there. Or let's just go back. Can you share your screen? I'll stop my own share now so you can share your own screen. Can we do that?
Yeah, fine. Okay.
All right, please let me end my share. Good. Okay. Okay, so from, I think we can, okay, so from here, right? Yes, this is fine. Can you change the get to a post? So that drop down, click on the drop down. Yes, so change it to a post. Yeah, so a post means we are trying to send some data, like so for APIs, you have different kind of verbs. So there's get, there's post, there's put, there's I think delete. There's several other things, but what to be working with the most is like get and post. So get is we are trying to get something from the server. We don't need to send anything to the server. We just want to get. But for post, we are trying to send some data to the server. So the data, in this case, we're trying to send some data for our server to make like some predictions on. So that's why we have to change it to posts. Then can you go to authorization? Yeah. Drop down. So the authorization type will be selecting is basic auth. Yeah, just on that Bearer token. Basic auth. Yeah. So the username is student user. It's all small letters. Yes. Then the password is student pass.
Small letters too.
Yeah, all small letters. Yes. So the next thing is to go to the body. The body tab. Yeah. Yeah. So can you select raw?
Raw.
Yes, raw. So there are different ways we can send our requests. So you can see as we selected raw now, it's set to text. But since we're not going to be sending, we're going to be sending JSON to the server, not a text object. So we have to change that drop down to text. To JSON rather, sorry. So you click on the drop down.
Text drop down.
Yeah.
Yeah, that drop down. So we're sending a JSON object, so it should be set to JSON, not text. Then can you go back to the slides? I already put a JSON of the data I want to make prediction on. So you can copy it and paste. Have you found the JSON object I put in the slides? Yes. Yes. Yeah, so this is the JSON object of what we're trying to predict for. So if you think about it, if we were trying to predict for, say, how likely a customer is to click on an SMS ad, based on some properties we've used to build our model. So this JSON would look like, instead of all these features we have here, it would be more like maybe the person's age, the person's SMS spend, the number of SMS the person sent for that month, the number of the spend on data, and those features are relative to like telco data. So it's this is like the input data for your model. So it depends on what you use to build your model. It depends on the columns you use to build the model. So it's a key value pair basically. That's how JSONs work. So you have the sepal length and the corresponding value, the sepal width and the corresponding value, and so on and so forth. So I think our request is ready to go. So you can just go ahead and click send. So all things being equal, you should be able to get a response. Did you get the response?
Sure. Where do I see the results?
Under the body. Can you scroll up a bit? Yeah, it should be under body.
Okay. Okay.
Okay, it seems there was an error. Can you go back to your command line?
Excuse me, sorry.
Yeah, can you go back to your
How do I share
command
my
line?
command line?
I think you have to create a new share because it's currently sharing on your postman. I think you have to stop this share and create a new share then you select your command line. Yes. Okay. So this error is from the sklearn. Let's go to one more. This error is from your from the sklearn library. So the library is trying to make the predictions. That's what's throwing the error. Can someone else try this? Can we try on someone else's system and see if it works? It shouldn't be. Does anybody else have this setup on their system? So we can also try it out because that error is not meant to be throwing that error. I think it's because of sklearn installation.
You signed up, right?
So this is a type mismatch. It's basically saying we have like a data type that I was expecting, but what we sent, it wasn't what it was expecting.
All right. So I can't even type on my command line to try and restore it.
Oh.
Okay. Don't worry. I'll work on another instance. If it's down.
Does anybody have this setup?
Someone should answer no or yes. No.
So if you have this setup, we can try on that person's machine because this error is not meant to be trying this error. So I guess it's with the installation. Okay. So I think we have to continue because I haven't finished the presentation yet, and this code session is taking longer than I expected. So I'll have to continue regardless of everybody not being able to run it. I think you can run it at a later time. So it's just the final step that's where the problem is. And I'm sure if someone else tries it on their system with like a different installation, it should definitely work. So I'll just continue the presentation. So I'll need everybody to kind of, hands off a bit from the code session and switch back to the presentation. I should be able to complete it in the next 10 minutes. Yeah. So I'll complete the presentation, open up the floor for questions. Then, we can continue. You can continue with the code session, and any questions you have, I'll be definitely available to answer the questions. But right now we're way behind schedule. Is that fine with everybody?
Yes, yes.
Yes, you can go ahead.
All right, thank you. Okay, so the next slide is, best practices for developing APIs for data science. So what I've done so far, I haven't gone in depth into building, APIs. Like, I just wanted to show everybody how APIs work, how we can build a very, very simple one. So what we've done is a very, very basic API. Usually, the API might come with several other functionalities and whatnot, but this is the barest minimum we need to get started. So, when you're developing APIs, there are some things you should look out for. Again, I'm not going to be going so in-depth into it, so I'll just be highlighting three things you should be watching out for when you're developing APIs for data science. So there are three things: data validation, response time, and the input data. So for data validation, when we build our model, right, our model is expecting our data to come in some certain form. For example, if I build my model and it's supposed to, it's expecting a number or an integer, right? If me as a user sends a text or a date format or a string to the model, it crashes because it wasn't built to handle that. So in that case, we need to make use of data validation. So data validation is basically saying that for every column, so for this current model that we built, right, we have 4 different variables. So to do data validation, we try to make sure that for each of those variables, they are all integers because we built the model with integer values. So it doesn't make any sense if you go to integer values and you are sending text or dates to it. So to perform validation, you basically, what you do is you write. I hope everybody is hearing me though.
Yes.
Okay.
Yeah.
Oh yeah, your mic is on and it's making a lot of noise.
Yeah, hello, can everybody hear me?
Yes, we can hear you, Femi.
Okay, okay, thank you. So the input data, like I said, it has to be JSON. So I'm sure while you are building your models and doing all these things, or while you're doing analysis, data format you've been working with, it has always been CSVs. Is that right?
Sure. Yes.
Has always been CSV, but when you are going into production mode, you can use CSV because there's an option to send CSV. You can send whatever data format when you are building API, but the ideal option is to use a JSON because almost all the systems, almost all software like systems, they use JSON. So it makes sense that you also adjust your own API to cater for JSON format. So whoever is sending data to your end, they have to send it in JSON. And you also have to send the response back, which is the prediction, in JSON format, like we've seen in the example earlier on. So the last section is handling large-scale deployments. And I'll just be talking about AWS SageMaker for a bit. So large-scale deployments, right? So the example we did is just one, is just one, is just one object we're trying to make a prediction on. It's just one flower. So you can imagine a system where you have thousands or even millions of requests every day or every week for you to make predictions on, right? This little thing we've done, like this little example we've done, might not be able to cater for such scale. And when you start dealing with scale like that, you want to be able to handle whatever comes your way, and you want to be able to do it such a way that you don't make so many errors, because as it scales up, like you're prone to so many errors. And you can write your own API from scratch, which should be much more complex than what we've currently done right now. But even at that, it's still very tricky. So ideally, most people, they tend towards like cloud solutions. So AWS, GCP, Azure, all these cloud solutions, they've kind of provided some machine learning solutions for users, such that the users specify a workflow, and as a user, you don't have to bother about the kinds of machines that that your app is going to be using. It's the cloud providers that worry about all of that. So if your request eventually gets as large as 1 million requests in a week, or 1 million requests every week, you don't have to bother about getting bigger machines. The cloud provider, they get bigger machines and optimized machines for machine learning. So you don't have to bother about that bit. So for that, like AWS has SageMaker that handles like training and deployment of models at large scale. So if you want to build your model on, let's say, a data set of 10 million to 50 million rows, ideally, if you do it on your machine, I don't even think you'd be able to load it into memory. But if you set it up on the cloud, you would have access to way bigger machines, which you only pay for usage. You don't pay for you don't pay for acquiring them. You pay for the number of hours you use them. So that kind of makes things a bit cheaper and easier to use. That's like the whole promise of cloud. So for the AWS SageMaker, right? It's their cloud service for training, building, and deploying machine learning models. It's managed, which means that you don't have to maintain the servers. You don't even know the size of servers there is. They've handled all of that already, and it grows as your request grows. So it's also designed to handle predictions of any size, ranging from it's several thousands to hundreds of millions, tens to hundreds of millions. So I've actually been in a scenario where I had to come up with a solution for making like millions, like making predictions on 5 to 10 million users every month. So what that means is that every month I want to be able to assign like a probability of a user clicking on an ad. So every month we want to be giving them new scores, right? And the solution we had at first only catered to a few tens of thousands or 100,000. But having to do for 5 to 10 million, I had to make use of AWS SageMaker. So that kind of helped, right? Because I had access to bigger machines, and the way they set up their own machines, everything was optimized. So I didn't have to bother about all of that. And I was able to make predictions on those millions of users in a matter of minutes, like 10, 15 minutes or 15, 20 minutes, I was done making like all these predictions. And also you could automate it. You could schedule it to run at specific periods. So you don't have to be the one manually clicking some things to make the prediction. You just set it up one time, and you can set it up to run every other week or every day or every month. So once you set all of that up, it runs automatically on its own. So that's like the really, really nice thing about using cloud solutions. Not just for large scale deployment, for any software engineering task really that requires scale. Cloud is, it's almost 90% of the time it's the best way to go. So that's the end of my presentation so far. I really appreciate you guys having me. I appreciate students having me over. If you guys have any questions, I think like before the final roundup, if you have any questions, you can just ask right away, and I'll kind of answer now. So thank you.
Thank you, Femi. As regards the struggles we're having right now,
Yes.
can we reach out to you? How do we reach out to you? Can you give us your email address or LinkedIn?
Oh, definitely.
Profile. Can we reach out to you?
Yes, definitely. So I have my email at the end of the slide. You can always reach me via email or send a message on LinkedIn. I'll definitely respond as soon as possible.
All right, thank you.
Yes, I'll still be available for any questions you have regarding this, especially regarding the code session, because I know we're not properly equipped, and there wasn't a lot of time to go through it. So yeah.
All right. Then API is more of data engineering than I call it the science part.
Yep.
Oh, okay. So you can't really use things like R or alongside.
Yeah, I mean, theoretically it's possible, but it's just not advisable. Exactly. It's really tedious. It's better to go with like proven solutions. Like Python, everybody uses Python. So even if you run into problems, there's support, all of that. So yes.
Aside from the data engineering part of your work, the data science part, like
yes.
the data features, the what's it called, the EDA parts in your projects. Yes. How do you really manage it? Because I've had to do a little EDA on some specific data set of just about 1,600, and I've been on it for over a week because it just seems like you keep finding different things at every point in time. So I don't know how you manage it that you don't get into a continuum of loss of time.
Oh, okay. Yeah, I mean, See, to be honest, you definitely have that because it's exploratory, right? So if you are given 6 months, you still keep on finding new things. But here's the thing: when you start working in companies, or you have to deliver some when you have some deliverables, basically, you are given a time frame, say 2 weeks. So within that 2 weeks, I think the skill is in trying to find out the most important things that might have like the highest impact. So within that 2 weeks, you wouldn't even have time to figure out like everything, right? So you just need to try to figure out the important things, which is kind of difficult because how do you know what is important and what is not important? But as time goes on, you would learn to set like to be able to assign priority to different things. So that constraint you have, because obviously you have all the time, so you would have to learn how to work with constraints, and
So
this
that
whole
comes
thing
in
is
practice.
exactly. So it might be tough the first time, right? Because you find new things and you not want to let go of those new things. You always want to keep on digging deep, and somebody just comes and say, "Oh, we need this so and so like right now. Can we get analysis by the end of the day?" And they're asking you, they gave a request this morning, and they're like, "Oh, can we have like a report by the end of the day?" I mean, obviously, you can't get like a full picture of what's happening like in depth, but the idea is to be able to get the most important things that might have an impact and communicate that. So as time goes on, you would learn how to pick like the important things. Yeah.
Okay, sure. So that's like an art. It's not like there's exactly a procedural aspect to that. So it's
Yep.
more like,
Yep. That's actually an apt way to put it. It's an art. It's not an exact science. It's not like you do this, do this, do this, do this, and you get this. It's more of you're exploring different things. So yes, it's more of an art. I hope that answered the
all right.
question.
Yeah, that very much answered. But one
Okay,
more
great.
thing, yeah, aside from SQL,
Yes.
Python, and probably R,
Yes.
what are the major tools that are necessary
Okay.
for one to be a
Um.
quick trader?
I mean, I guess it's subjective depending on like the environment I'm working in. But I think Python and SQL, they cover like say 70 to 80% of the entire like workflow. So if you know your Python or your SQL very well, then I think you've done really good enough. And the extras that would be nice to have is um, I think Spark. So Spark is for big data processing. When you have to do like work on huge data sets, you don't always run into that. But I've been in like situations where I've had to write a little bit of Spark code. So there's Spark, yes, there's Spark. There's let me see. It's also good to have like a good knowledge of all these cloud technologies because like most of their stuff is on the cloud. So if you can know like some services, for example, AWS has S3 for file storage. They have AWS Glue for ETL. But even within those services, you still have to write Python code or Spark code or some other like SQL code. So it still comes back to Python, SQL, and maybe Spark. But I think Python SQL covers because most of the work I've done in the past. I mean, I've been working for too long, but most of the work I've done is basically Python and SQL. Always been Python and SQL. I haven't done Python and SQL.
But then most of the authentications I see people use or files that they bring in or send out is usually in JSON. So we don't necessarily need to know JavaScript. So
No. You don't need JavaScript. All those requirements for job descriptions and what like all those things are really, really bloated stuff. If chances are the person that even put it is not even a technical person. The person saw it on another company's website, decided to copy and paste the whole thing, and they just put it out
That's
there.
ridiculous.
I just put it out there that you have, and they list out these technologies, endless technologies that no one person has everything. So more often than not, the requirement is not really like those job description and the requirement for roles are not as honest. So yes.
Then again, I was going to ask, what tool would I say is the best to actually learn Python or to upgrade your Python skill? Because I've been
What
using it for
tool?
a couple of years.
Oh,
Like
okay.
all these code compo, even if it's a book or something.
For
To
Python, I think Udacity does a good job of introduction to Python, right? So the trick about it is that for Python, when I say Python, like half the time, I'm actually talking about pandas. So
yeah,
pandas is the library for data analysis, and obviously was built using Python. So you see us write Python code for both. So if you have a very good understanding of what Python is, you have like an introductory knowledge, right? Then you can start to study the pandas library and try to do a lot of tasks using pandas, because it's easier to learn when you do different tasks like using pandas, because that's what has helped me. Because since I've known like a ton of stuff in pandas, not because I was necessarily learning it on my own. It's because I had to use it and I ran into problems and I had to dig deep. Then I found out something about it, and that basically builds the knowledge for like the next task I have to do. So it's more of, practice makes perfect. So it would be good to start now to, all those things we used to do in R, you can try to implement those things in pandas. And I think that should help. I think that should help.
thank you. So, what cloud services do you think should have like a preference for learning or something for people that are just really
Um,
good with cloud services?
yeah, for cloud services, I mean, I'll have a bias for AWS because everywhere I've worked, there's always been AWS. But there are companies where they use GCP, and I've not seen a lot
IBM.
of companies. No, I've not seen a lot of companies. I've never seen any company use IBM, and I've not seen a lot of companies use Azure. But I know GCP and AWS are the major containers. Again, like I would have whatever I'm saying now, it's obviously there's going to be a bias because it's be based on where I've worked and what I've seen. But I think those two are pretty much like a good place to start.
AWS and what?
GCP, Google Cloud.
Hi, Femi.
Hi.
Can I ask you on the interview process? Like maybe you said, because I went through your LinkedIn, I saw Terragon and in the China. So like, how was
Yes.
the
Interview
interview
process.
process? Yeah. And
Okay. So the interviews are really like for example for Terragon, I had like maybe 2 technical interviews really. And the people that were interviewing me at the time, they were not necessarily senior people in like data science, because then they were just trying to get the team together. So they had people that maybe they were doing software before, then they had interest in data science, right? So so that, in that way, I wasn't like they didn't fire me with a lot of super technical questions, right? So right now we don't have a lot of people we don't have a lot of senior people in data science that they would ask you really technical questions, right? Most roles you will see they are probably just starting out their data science thing. So like right now is actually the best time to get in. So as long as you know the basics of machine learning, data science, analysis, they might ask you that, they might ask you So they might ask that you walk them through like an analytical problem. So they might throw like a data set to you and they'll give you like a data analysis challenge. Like, okay, we'll give you this data. Can you say this and this about this? Can you say what causes this? Can you build a model to do this? And so on and so forth. So right now, it's usually not really super technical. So if you're comfortable with the basics, I think you should do well on that. So yes, I think yeah.
Okay, thank you. One more thing. I don't know if maybe you struggle with it. Imposter syndrome, feeling like maybe you don't know so much, but
Yeah.
and you know, I don't know, how does that go? Because you enter
Yeah.
into the field, you might feel like you don't know so much, but
Yeah. I think that's actually legit because I've like starting out, I've obviously had like imposter syndrome, right? Like you go for interviews or you're asking people that you want to do something here, but you deep down you're like, you're conflicted. Like all these things I'm saying, like, can I actually do it? Right? I mean, that's very, very normal. But I think the important thing to even note is that most, most, at least in Nigeria, right? Most places where you would apply to, more than half of them, they're not really sure about how it works. Like they're not even as knowledgeable, right? So I don't know if that's a good thing, but I think it's something that you can find like some comfort in. Like if you can think about it this way, that if you can think about it that where you are going to the interview, people that are supposed to interview, they are not even as knowledgeable, then that kind of reduces the pressure on you, right? So that's one thing I've tried to have at the back of my. So if I'm going to apply to any job or I want to ask somebody for an opportunity or I want to apply to an internship or even like I think apply for internships is even a very safe thing to do because then internship nobody really expects you to know all the answers to all the questions. So that's like a perfect way to try to get in because that's basically what I did when I first started. I was basically looking for internships here and there. So I mean if you've done like a few months of internship, that kind of builds your confidence exactly. So it's not
So are there
as yeah.
specific organizations that actually request for interns or just normal LinkedIn scouting for internship?
So I mean that there first of all there are not a lot of companies that actually do like data science and whatnot. But now there's a lot now. But before at least when I started there weren't a lot, so my options were kind of limited. So for internships, I don't know a lot of companies. So the way these things work is the most effective way is knowing other people. So you get to hear about a gig through somebody else. So that's why it's good like to build networks. So you go for meetups, you meet people with similar interests, you talk a bit, and if something comes up, you will hear it through like your network of other like-minded people. So as for companies that do internships, I can't really speak to. I know Terragon does internships. We had like a couple of interns come and go. So I think Terragon is it's a good place. Where I'm working now also, we had like we have two interns at the moment, right? So I would obviously say in the channel also. Um, I know people working at Rare Money as data scientists. I think Rare Money is also a place that you can mark down for later. Pay later also. Pay later, yeah. Pay later is like Pay later is I don't know. I didn't remember pay later as first, but pay later or carbon. Yeah, carbon is also a good place to mark down. I think that's about it. But yeah, that's what I can think of right now.
Thank you.
Okay. Good evening, Femi.
Hi, good evening.
Yes. I was not at the beginning of your talk. I had to
Okay,
squeeze time out of work so that I can be here.
okay.
But I
Oh,
see
great.
when I went through your presentation, you mentioned something. I saw something about flask being one of the requirements.
Yes.
I
So,
remember taking a tutorial once about
okay.
using Flask and Django, and it was mainly on Python. So is Flask like a Python thing? Or
Exactly. It's a Python library.
okay,
It's a
so that
Python
means
library.
when we're developing APIs, we mostly use Python, right?
Yes, yes, Python. Yes. That's the go-to. Yeah, Python.
Okay,
Yes, Python. Python is a go-to for developing APIs. So if you are going to be doing a lot of writing APIs, deploying and whatnot, Python is the de facto, at least for data science stuff.
all right,
Yes,
all
sir.
right. Thank you. Please permit me. I'll have to go through some of this things again. I don't know if I can reach you after now for any other questions.
Oh yeah, definitely. So I have my LinkedIn on the at the end of the slides, and also my email. So you can reach me on either of them.
All right. Thank you very
I'll
much.
leave a reply as soon as possible.
All
I
right.
think I can take one more question before we finally wrap up because we are way, way, way behind schedule. We're supposed to take 1 hour, but yeah, it's already 2 hours. So one more question.
Femi.
Hi.
Yeah, I wanted to ask if you currently work remote or you have like a day-to-day office thing.
Oh, okay. Right now I'm full time. I'm currently employed full time. Though it's kind of remote friendly. I get 3 days remote, but then 2 days I have to be in the office for 2 days out of 5 days in a week. So it's remote friendly, but it's full time. Yeah.
All right, thank you.
Yes, sure thing. Yeah, so I think we've come to the end of this very, very long session. I really appreciate you guys having me over to talk a little bit about what I've done and and all that stuff. Sha. So yeah, I really appreciate you guys having me. I hope you guys really took something out of this session, and in the future, like our paths get to cross again. So thank you very much for having me.
Thank you so much, Femi. Really appreciate it.
Yeah.
Yeah,
Thank you.
yeah. So, so if you have any questions, regarding the code session, please just don't hesitate to leave me a message on email or my
All right,
mail.
Sure.
thank you.
Yeah. Thank you very much. Enjoy the rest of your
Thank
day.
you.
Yeah.
Yeah,
Bye.
thank you.
Thanks, bro.
Sir.